Welcome to your Algebra 2 lesson on section 3.6. Today we're going to learn about matrix multiplication. So you're going to learn how to multiply matrices. So we're going to multiply, instead of scalar multiplication, where we multiply the whole matrix by a scalar, say 2, or you just, in that case, multiply each element by 2, we're actually going to take one matrix and multiply it by another matrix. And I'm just going to tell you, I don't think this is a process that you would just kind of come up with intuitively. It's definitely a process you have to learn. So this is going to be a lesson where you want to take really good notes and make sure that while you're doing the examples, you're really paying attention to how they're done. All right, first of all, let's talk about when it's defined, because it's not always defined. You can't just take any two matrices and multiply them together. The product of two matrices A and B is defined provided that the number of columns in A is equal to the number of rows in B. So if A is an M by N matrix and B is an N by P matrix, then the product AB is an M by P matrix. Now I think it's easiest to see this with symbols. So there, if you look, I've got A times B equals AB. So A has dimensions M by N, and then B has dimensions N by P. Okay, as long as the number of columns in A is equal to the number of rows in B, you're good to go. So those middle numbers, if you write it right next to each other in the order of operation, multiplication, A times B, so A has dimensions M times N, B has dimensions N times P. It's really important that you write the dimensions of A first and then write the dimensions of B. You can see that those middle numbers N match up. On your notes, since I can't really make colors stand out on that, I just drew a box around those two matching. The outside two values, the M and the P, tell you the dimensions of the matrix that will result. So AB will have M by P dimensions, so M rows and P columns. Okay, let's look at an example now. Let me go find my example slides. We're going to look at an example where we just check the dimensions, and then we'll come back and we'll talk about matrix multiplication in particular, how to do it, and then we'll look at an example of that. And that'll be it for video 1. Then we'll come back for video 2. Okay, we're going to state whether the product AB is defined, and if so, we're going to give the dimensions of AB. Okay, so for A, example A, matrix A is 4 by 3 and matrix B is 3 by 2. So because A is a 4 by 3 matrix and B is a 3 by 2 matrix, so if we write 4 by 3 next to 3 by 2, those middle numbers match. So that means that the product AB is defined and the dimensions will be 4 by 2. You just look at the outer two dimensions. The rows of A and the columns of B will tell you the dimensions of the new matrix. Let's look at part B. If you look at 3 by 4 and then 3 by 2, if you write them next to each other, the 4 and the 3 don't match up. So we're not going to be able to do that multiplication because the number of columns in A, which is 4, does not equal the rows in B's, which is 3. The product AB is not defined, so we can't do the multiplication. Now, the answers to, well, why not, will hopefully be given to you when we talk about how to multiply matrices, because the multiplication process is done row by column. Okay. Matrix multiplication is done by multiplying rows of the first matrix by the column of the second matrix. And we're going to look at an example in a minute, but first let's look at, well, I guess this is kind of an example, but it's in general because we don't have any numbers. We just have little variables sitting in our elements. So matrix A is A, B, C, D. Matrix B is E, F, G, H. And when we multiply them together, we multiply the rows of A by the columns of B, and that gives us AE plus BG. That's the first row of A multiplied by the first column of B. And then AF plus BH, that's what we get when we multiply the first row of A times the second column of B. So I just want to point out the first row of A is going to multiply by each column in B, and that's going to give us the elements of our first row of our product matrix. Then we move to the second row, and we do CD times EG, and that gives us this element here, the CE plus DG in the second row, first column. And then we do the same thing. We do CD times FH, and that gives us CF plus DH, and that is from the second row times the second column, so it goes in second row, second column position. Let's look at each one of these individually. So first thing you do is you start with the first row of A and you multiply by the first column of B. And the way you do that is you take the first element in that first row and multiply by the first element in that first column, and you get AE, and then you write down plus, and you move to that second element in the first row and multiply by the second element in the first column, and so you get plus BG. So it's a combination of multiplying and adding. But that's how you multiply the first row times the first column. At first it'll feel weird, but by the time you're done with, maybe even done with the problems to try on your own, it might feel natural, but certainly after you do the rounds, it'll feel natural to you. Okay, now we're going to do the first row of A times the second column of B. So we're going to do AB times FH. So you do the first element of that first row, so we do A times F, and then we do plus, and then we move to the second element, so we do B times H. And so the element in AB is going to be AF plus BH. Okay, we've run out of columns in B, so now we move down to row 2 in A, and we're going to multiply CD first by the first column, and then we're going to come back and multiply by the second column of B. So we have C times E plus D times G. And when you have numbers, you'd actually do that multiplication and addition, and you'd come up with a single value there for AB. And finally, we do second row times second column, and so that gives us CF plus DH. And that gives us our second row, second column element in our product matrix. Okay, so let's go look at an example, because it's so much easier to see this, I think, with an example. We're going to find AB if A equals 1, 4, 3, negative 2, and B equals 5, negative 7, 9, 6. Now, order is really important, so you have to write it as A times B. Okay, that's very important for you to understand. You also always want to double check that the multiplication is going to be defined by checking the dimensions. Since A is a 2 by 2 matrix, B is a 2 by 2 matrix, the two middle values match up. The two outer values tell us that the product matrix will be another 2 by 2 matrix. Okay, so step 1, we're going to multiply the numbers in the first row of A by the numbers in the first column of B, add the products, and put the results in the first row, first column of AB. So you can see on the PowerPoint here, we've written the elements of the first row of A in red and the first column of B in blue. And you can see we do 1 times 5 plus 4 times 9. Okay, now we're ready for step 2. We're going to multiply the numbers in the first row of A by the numbers in the second column of B, add the products, and put the results in the first row, second column of AB. So there's a little typo there. It should say second column of B. I can't fix this because it's not an editable PowerPoint, so I apologize for that. All right. So on this one, the negative 7, 6 are going to be what we multiply by. So we do 1 times negative 7 plus 4 times 6. Okay, because we're doing that first row by the second column. And so the answer goes in first row, second column. All right, step 3, we're going to multiply the numbers in the second row of A by the numbers in the first column of B. And we're going to add the products and put the results in the second row, first column of AB. So we're going to have 3 times 5 plus negative 2 times 9 because we're using the second row in the first column. So guess what step 4 is? Yep, we're going to do the second row of A and multiply by the numbers in the second column of B, and we're going to put the results in the second row, second column of AB. Okay, so that's what we're going to do. So we do 3, negative 2, and then we're multiplying that row by negative 7, 6. So we have 3 times negative 7 plus negative 2 times 6. Now we just need to simplify. Let's see. 1 times 5 is 5, plus 4 times 9, that's going to be 5 plus 36, and that gives us 41 in the first row, first column. In the first row, second column, we get negative 7 plus 24, which is 17. And now we're ready to move to the second row. Second row, first column, we have 15 plus negative 18, so that gives us negative 3. And then finally, second row, second column, we've got 3 times negative 7, so negative 21. And then negative 2 times 6, negative 12. Negative 21 plus negative 12 is negative 33. Okay. So that is the product matrix of A times B. Okay, well, I have to change presentations anyway here, so this is a good stopping point for the first video. I'll see you again in just a second for video 2 of lesson 3.6. So I'll see you in just a minute.